This video focuses on the inline version of the power panel. We call it an inline version because it has two jacks and allows you to go in between a switch that's driving the PoE device and the PoE device itself. This gives you some remarkable additive testing power that's not available in the single jack unit. Now, if you looked at the single jack unit, you saw that the power panel scans all the pins looking for network devices, phones, and power. The inline version does all of that. The inline version also can force link pulses for communication, and it can simulate a VoIP phone or an IP camera, just like the single jack unit can. But if you're an IP camera installer or you install VoIP phones, then you need the inline version because you can measure watts. And watts is the #1 reason why these networks go down, drawing too much power out of the switch. Let's give you an example. Here we have a computer network made up of an IP camera. We also have an access device for wireless computers. You might find something like this in the attic of a Starbucks. Both of our devices are driven by power over Ethernet. Notice that neither of them have separate AC power. Now imagine further that I am an IP camera installer, and my job is to get this thing working in the far end of a warehouse, and I go ahead and plug in and it doesn't work. The IT manager has already told me that all of the ports on my switch are putting out power over Ethernet voltage, but I have no way of measuring that. I also have no way of knowing whether I have a data path, like every computer device needs. And that's where the inline power panel comes in. I connect in between my switch and the PoE device, and immediately I see that there is a network device and there is power over Ethernet available. If I wish to learn more, I go to the correct screen. Here I'm on the network screen, and it says that it sees a device that is 100 megabit a second full duplex on 1, 2, and 3, 6. I also see the data is flowing by looking at my dancing data display. Now let's switch to the power over Ethernet screen. It says that I have PoE N-span voltage, also on pairs 1, 2, 3, 6, the same pairs that the data reside on, and that I have my 47 volts of PoE drawing 4.3, 4.4 watts. Now I have all the information that I need. I know where my data pair is, I know that I have power, and I know how much power that consumes. Now let's go over to our access point. It likewise knows separate AC voltage powered by power over Ethernet. I'm looking at the PoE screen now. Similarly, it sees 46 to 47 volts on 1, 2, 3, and 6. See how much power it's drawing, 4.1 watts. Now let's go ahead and flip over to our network screen. It sees the same switch, also on 1, 2, 3, 6. If I had a network where I was injecting PoE power mid-span, let's say on a rack, then that would show up on 4, 5, 7, and 8, and mid-span power would be indicated. Now, if I did not have an inline power panel, I would have to revert back to the old method of testing for power. And this is not what you want to do on the job. You want to use the new method, the inline power panel, to get your work done safe and efficiently. And in this complicated world of power, for instance, with this Linksys switch, it says that it can handle 60 total watts. But it further says that it can handle 4 ports at 15 watts or 8 ports at 7.5 watts. So you can see with the Power Panel DBM inline version that we have everything under control.